Question number 10 is integrate from 0 to pi x sine of x dx over 1 plus cos square of x. Let this integral equals to I. This will be I equals to 0 to pi x sine of x dx over 1 plus cos square of x. Now using here your theorem of book 5.9 that is given on page number 176, that theorem says that you need, if you have a function from 0 to a f of x dx, you can just replace your this x with a minus x, upper limit minus x. Using this theorem here in this question number 10, what is our upper limit here? Our upper limit here is pi. So I can replace my x with pi minus x here. So in place of x, I am writing here pi minus x, sine of pi minus x over 1 plus cos square of pi minus x. Now we can open our this term and this term. It will be, if we have sine of pi minus x, I will use here the formula sine of alpha minus beta. That will be equals to sine of alpha cos of beta minus cos of alpha sine of beta. I have here sine of pi minus x. That will be equals to sine pi cos x minus cos pi sine of x. We know that sine pi is 0 and we know that cos of pi is negative 1. This negative and this negative will give us the positive, and we have here sine of x in our answer. Now we need to solve this cos square of pi minus x. We know that cos of alpha minus beta equals cos of alpha cos of beta plus sine of alpha sine of beta. Here we have cos square pi minus x. We can write it like cos of pi minus x whole square. Now we can write it like cos of pi cos of x plus sine of pi sine of x whole square. Due to this sine of pi, it will goes to 0, and here we will have minus cos of x whole square. That is equals to cos square of x. So I equals integration 0 to pi minus x sine of x over 1 plus cos square of x dx. Now we can separate our integral because in our numerator we have pi sine of x minus x sine of x. We can just separate our denominator into two parts like this. So it will be split like I equals to 0 to pi sine of x dx over 1 plus cos square of x minus this negative sign 0 to pi x sine of x over 1 plus cos square of x dx. If you observe, you have this one the same as your question. Your question is same, 0 to pi x sine of x over 1 plus cos square of x dx. So it is the same thing. So I am just replacing it with the name. I just let it equals to the question, that is the I. Now I can move this negative I on my left hand side, so both of them can be combined, and I will get here I plus I, so that will be equals to 2I. So 2I equals integration from 0 to pi sine of x dx over 1 plus cos square of x. Now this 2 is multiplying with this I can move it on the right side. It will become 1 by 2 0 to pi sine of x over 1 plus cos square of x dx. Now I need substitution here. That is, let cos of x equals to t. Derivative on both sides will give us minus sine of x dx is equals to dt. And I have here sine of x dx. So I can separate sine of x dx out of here. I will get sine of x dx equals to negative dt. Now, since we are changing the variable, we need to change our limits of integration as well. We know that this lower limit and the upper limit is on x variable. So when x approaches to 0, here, cos of 0 will give us the 1. So t approaches to 1. So my lower limit will be 1 here. Now, when x approaches to pi, here, I will get cos pi, and cos pi will give us negative 1. So my t approaches to negative 1. So my upper limit is negative 1 here. Pi will be written as it is. Sine of x dx is negative dt. 1 plus cos square of x will give us 1 plus t square. move this, I know that I can change this limit sign, limit of integration, because you know that the lower limit must be less than the upper limit, but here the upper limit is less. So just change the order of the integration, limits of integration. If I am changing the order of limit of integration, I need to write the negative sign. That negative sign and this negative sign will combine, will give us the positive one, and I have from the negative 1 to 1 dt over 1 plus t square. We know that this is the formula for tangent inverse of t, and the limit of integration is from negative 1 to 1. Now put the upper limit first. It will be pi by 2 tangent inverse upper limit negative tangent inverse lower limit. We know that tangent inverse of 1 is pi by 4 and tangent inverse of minus 1 is negative pi by 4. That negative pi by 4, if combined with this negative, I will get plus pi by 4 here. And if I solve this one, I will get here 2 pi by 4, that is equals to pi by 2. That pi by 2 and this pi by 2 will give us pi square by 4 in my answer here. Question number 11. Integrate from 2 to 4 under root ln 9 minus x over under root ln 9 minus x plus under root ln 3 plus x. Let this integral equals to I. I'm naming this as equation number 1. I'm here taking this substitution. This is the different substitution as we did earlier in the previous questions of this chapter. Just keep it in your mind that what type of substitution you are taking here. Let n9 minus x equals to 3 plus y. Let 9 minus x equals to 3 plus, I'm changing the variable here. Let 9 minus x equals to 3 plus y here. So negative x will be, move this 9 on the other side, it will be negative 9 plus 3 plus y. So I will get here from negative 6 plus y. Move this negative sign on the right side, just change the signs here, you will get x is equals to 6 minus y. Now derivative on both sides will give us dx is equals to negative dy. This is your substitution. Now we need to change the limits of integration as well. You know that when x approaches to 2 here, when x approaches to 2 here, in this, that is 9 minus x is equals to 3 plus y. When x approaches to 2 here, it will be 9 minus 2 is equals to 3 plus y. This thing will be 7. Move this 3 here, it will be 7 minus 3 is equals to y. So you will get y is equals to 4. So when x approaches to 2, you will get y approaches to 4 here. And when x approaches to 4, put the 4 here in place of x, we will get y approaches to 2 here. So our limits of integration are from 4 to 2. And replace the values. 9 minus x. 9 minus x is equals to 3 plus y here. Dx is equals to negative dy, like this. 9 minus x is 3 plus y. Now I need here 3 plus x. 3 plus x. It is 3 plus x. This will be equals to 3 plus. What is the value of x here? That is 6 minus y. So I got 9 minus y here. So replace it with 9 minus y. Now I can change this limit of integration because you know that the lower limit is greater than the upper limit. So move it, change this, replace, and if you are changing their place, you will put the negative sign here. So changing their place, the things will remain here as it is, and I will get here, this is the negative dy. Negative and negative will give us the positive. I will get in integration from 2 to 4 ln 3 plus y under root over ln 3 plus y under root plus ln 9 minus y. I know that if I have a to b f of x dx, I can write it like a to b f of y dy as well. Both will be the same. So in place of y, I am writing here x. I will get I equals, limit of integration is from 2 to 4 ln 3 plus x under root over under root ln 3 plus x plus under root ln 9 minus x. Now I am adding my equation number 1 with equation number 2. If I add equation number 1, equation number 2, the left hand side will be added with the left hand side and the right hand side will be added with the right hand side. I will get here 2i equals You see here, this is the same limits of integration. If you have the same limit of integration like a to b f of x dx plus a to b g of x dx, you can combine the functions in the one limit of integration. That will be your f of x plus g of x dx like this. Both of them have the same limit of integration, so I am combining both the functions and I am adding them. You know that the denominators is same, so the numerators will be added like this. So I got this thing in my answer here. Now this is 2i, 2 is multiplying here, it will divide it on the other side. You see here your numerator is equals to the denominator, it will be cancelled. So you will get here 1 dx in your answer here. Now you know that the integration, this is simple x and the limit of integration is from 2 to 4. Upper limit minus lower limit in place of x. I will get here I is equals to 1 by 2 into 2. This will be cancelled. So I is equals to 1. And what was I? I was my question. That is I have written here. So this limit integration is equals to 1 here. Question number 12. From the question number 12, you need to show your equations that are given. First of all, in the question number 12, you need to show that limits of integration applied if on this function, you will get 0 in your answer. Integration from 0 to pi by 2 ln tangent x dx. You can also name it as equals to I as well. It's up to you. Since this is not as the lengthy function, so I have not let it equals to I because it is difficult to write the lengthy functions again and again. You can just write it as it is as well, but if you want to name it as equals to I, you can name it. Okay, tangent x can be written as sine x over cos x, and we know that this is a property of ln. If you have ln sine of x over cos of x, you can write it like ln sine of x minus ln cos of x like this. So I will write it like separately, and then I just split the integration into two parts like this. So I got 0 to pi by 2 ln sine of x dx minus 0 to pi by 2 ln cos of x dx here. Now I know that I can write this thing using my theorem. You know that this is your theorem, that if you have 0 to a f of x dx, you can write it like integration from 0 to a f of a minus x dx, upper limit minus x. So I am here, my limit, upper limit is pi by 2. So I can replace my x with pi by 2 minus x here. Same thing I did it in the second integral. You can change it here as well, but I'm not changing it here because I know that if I solve this integral, I will get back the same integral according to the second one, so that I can cancel them. So just don't touch this integral, just keep it as it is. Just replacing x here with pi by 2 minus x and open it. This is an identity as well. You can directly write it as cos of x, but if you don't remember that what it exactly equals to, you can open it using this formula. Sine of alpha minus beta, that is equals to sine of alpha cos of beta minus cos of alpha sine of beta. Open it according to this identity, you will get ln cos of x here. You see, both the integrals are same now with the opposite sign, so they will be cancelled and you will get 0 in your answer. So this is prove that the limit 0 to pi by 2 ln tangent x dx is equals to 0 here in this question 12. Question number 13. Prove that integration from 0 to pi by 2 sine 2x ln tangent x dx equals to 0. Again, using the same formula, same theorem that I used here, you can replace your x with upper limit minus x. Your upper limit here is pi by 2. So I can replace my x with pi by 2 minus x. So replace your x with pi by 2 minus x here. This x is pi by 2 minus x again. Now multiply 2 inside. This will be 2 into pi by 2 minus 2x. So I will get here pi minus 2x and ln cotangent x. This is again the same identity. You can use the formula of tangent to open this as well, or if you remember the direct identity, you can directly replace it with this. And you know that what it exactly equals to. That is equals to ln cotangent x. Now you can open the same thing, the same identity as I told you here, or you can directly use identity if you remember that formula. it will be equals to sine 2x and ln cotangent x. This cotangent x, I know that this can be written as ln 1 over tangent x. And this is equals to ln tangent x negative 1 power 1. So it can be moved down and it will becomes minus ln tangent x. This negative sign is moved outside and I have written limit of integration from 0 to pi by 2 sine 2x ln tangent x dx here. Now, what was our question? Our question was 0 to pi by 2 sine 2x ln tangent x dx, and on the right hand side I got the same thing but with the negative sign. I can move it on the left side. It will become plus. So plus this integral I will get 2 times this integral equals to 0. Now I can move this 2 on the other side. It will be divided. So I will get here 0 in my answer. So the same thing we need to prove in this question, that this integral is equals to 0. So I proved here that this integral is equals to 0. Now move on to the question number 14, that says integrate from 0 to pi x tangent x over secant x plus cos of x dx, that is equals to pi square by 4. I equals to integration, let's suppose this integral equals to I, that is equals to integration from 0 to pi x tangent x over secant x plus cos of x dx. Open this identity tangent x, that is equals to sin x over cos x, and open this identity secant x, that is 1 over cos of x. Now take the LCM here in the denominator, you will get 1 plus cos square of x over cos of x. This cos of x can be cancelled with this cos of x. So I will get here I equals 0 to pi x sine of x over 1 plus cos square of x dx. Now again using the same theorem, that I can replace my x with upper limit minus x. So just replace it with x with pi minus x sine of pi minus x over 1 plus cos square of pi minus x. Now open this identity. This will be sine of pi cos of x minus cos of pi sine of x. You know that this term goes to 0 and cos of pi is negative 1. So negative will become positive sine of x here. And cos square of pi of x, cos square of pi minus x, this will be equals to cos of pi minus x whole square. And you need to open it. This will be equals to cos pi cos x plus sine pi sine of x. This term goes to 0. And here you will get minus cos of x whole square. This is equals to cos square of x. This is the same thing you got that we did right now in the previous question. Now you can separate it into two parts, pi sine of x over this thing and negative x sine of x over this thing, and break your integration into two parts with both the functions. You will get I equals to 0 to pi sine of x over 1 plus cos square of x, negative 0 to pi x sine of x dx over 1 plus cos square of x. This is equals to I, the same thing. So move it on the left side. This is minus I. If I move it on the left side, I will get I plus I here, that is equals to 2I. So 2I equals pi 0 to pi sine of x over 1 plus cos square of x dx. Now this 2 can be divided on the other side. I will get I equals to pi by 2 0 to pi sine of x over 1 plus cos square of x dx. Again using the same substitution as we did same question in the previous parts. Let cos of x is equals to t. Derivative on the both side will give us minus sine of x dx dt. Move the negative sign on the other side because I have here sine of x dx only. This will be equals to sine of x dx is equals to negative dt. Now I need to change my limits of integration as well. The lower limit on x is 0. When x approaches to 0, you will get cos 0 is 1, so t approaches to 1 here. When x approaches to pi, cos of pi will give us negative 1. So t approaches to negative 1 here. And now substitute the limits of integration here. You will get 1 to negative 1 minus dt over 1 plus t square. You know that I can change this limits of integration to this negative sign I have taken outside. Okay, don't take it outside, keep it inside so that you will be have no confusion here. Now I am changing limit of integration position, so it will be negative 1 to 1 and write the negative sign. This negative and this negative will become positive, so I will get pi by 2 minus 1 to 1 dt over 1 plus t square. This is the integration tangent inverse of t from negative 1 to 1. Put the limits of integration here, you will get tangent inverse of 1 minus tangent inverse of minus 1. This is equals to pi by 4 minus pi by 4. So this will be pi by 4 plus pi by 4, 2 pi by 4. So it will be pi by 2 here. So pi by 2 into pi by 2 you will get here pi square by 4. So you need to prove the same thing, that this integral is equals to pi square by 4. So it is proved here. Question number 15. Integrate from 0 to pi by 2 under root sine of x over under root sine of x plus under root cos of x dx, that is equals to pi by 4. Consider your left hand side equals to I. Now using the same theorem, replace your x with upper limit minus x. You can replace it. In place of x, I got sine of pi by 2 minus x over under root sine of pi by 2 minus x plus under root cos of pi by 2 minus x. Open these terms. I repeatedly told you how you can open it. You can use this formula. Cos of alpha minus beta is equals to cos of alpha cos of beta plus sine of alpha sine of beta. And if you have sine of alpha minus beta, that is equals to sine of alpha cos of beta minus cos of alpha sine of beta. Use this formula to open it. You will get I equals to 0 to pi by 2 under root cos of x dx divided by under root cos of x plus under root sine of x. Now I can write this under root sine of x. I can add the same thing here, but I need to subtract as well. Now I can separate this denominator into two parts. If I separate it into two parts, I will get in the first integral under root cos of x plus under root sine of x over under root cos of x plus under root sine of x. That will be cancelled. I will get here 1 dx. Negative sign 0 to pi by 2 under root sine of x over this denominator dx. This is the same integral as this I. So I will write here negative I. This negative I will be moved on the left side and it will I plus I will give us 2I. That is equals to integration 0 to pi by 2 dx. And that is equals to 2 will move on this right side, 1 by 2 integration 0 to pi by 2 dx, and integration of dx is equals to x from 0 to pi by 2. Now upper limit minus lower limit, this will give us pi by 2 here, and pi by 2 into 1 by 2 will give us pi by 4. So this is the same thing that we needed to prove here in this question number 15. Now question number 16 is the lengthy one here, and I think this will be difficult for you as well, but let's see how we are going to solve it. Question number 16, integrate from 0 to pi by 2 sine square of x dx over sine of x plus cos of x. You need to prove it that it is equals to 1 over under root 2 ln under root 2 plus 1. Let this left hand side equals to I. Replace your x with upper limit minus x. So it will be sine square pi by 2 minus x over sine pi by 2 minus x plus cos pi by 2 minus x. Use the same formula to open these things. Sine of alpha minus beta is equals to sine of alpha cos of beta minus cos of alpha sine of beta. Use the same identity to open it. And for cos of alpha minus beta, you have the formula cos of alpha cos of beta plus sine of alpha sine of beta here. Use these identities to open this. You will get here I equals integration from 0 to pi by 2 cos square of x over cos of x plus sine of x dx here. Now you know that you can open this cos square of x as 1 minus sine square of x using the identity, that is cos square of x plus sine square of x equals to 1. So cos square of x will be equals to 1 minus sine square of x. Replace it with this identity. Now you have two functions here in your numerator. You can just break your denominator into two parts with these numerators. It will be 1 over cos of x plus sine of x minus sine square of x over cos of x plus sine of x. If you observe, you got the same integral as this I. This is the same one with the same limit of integration as well. So I just replace it with negative I here. Move this negative I on the left side. It will be I plus I, that will give us 2I. And this thing is written as it is. That is 0 to pi by 2, 1 over cos of x plus sine of x dx. Now, I can solve this by this method. How? I want to complete here this kind of formula, this kind of thing. For that purpose, I need here some other constants as well. And the same thing, same angle I need here. I am multiplying this thing with 1 over under 2 and dividing it with 1 over under root as well. 1 over under root 2, this 1 under root 2 will come outside. It will become 1 over 2 into under root 2. 1 over under root 2 cos of x plus 1 over under root 2 sine of x. We know that cos pi by 4 is 1 over under root 2. And also sine pi by 4 is 1 over under root 2. So I will replace this 1 over under root 2 with cos pi by 4 and this 1 over under root 2 with sine pi by 4. So if you observe, you got here cos pi by 4 cos of x plus sine pi by 4 sine of x. And what this formula is equals to? This is equals to cos pi by 4 minus of x. So just replace it with this. So now you see this function is summarized. And 1 over cos x minus pi by 4, you can write it like secant x minus pi by 4. So this is equals to I equals 1 over 2 under root 2, 0 to pi by 2, secant x minus pi by 4 dx. And you know that what is the integration of secant x dx? It is equals to ln secant x plus tangent x. And x here is x minus pi by 4. So in place of x, write x minus pi by 4. And the limits of integration are from 0 to pi by 2. Now first of all, you will put the upper limit here. And this is the thing for the upper limit. Then formula minus and put the lower limit in place of x. Upper limit, it will be ln secant upper limit minus pi by 4 plus tangent upper limit minus pi by 4. Then formula minus ln secant lower limit minus pi by 2 plus tangent lower limit minus pi by 4. You will be very conscious while doing this step because it has lots of brackets here. So you will get confused or you can just have some mistake here. So just focus on this step clearly so that you can just write it correctly. You will get here ln pi by 2 minus pi by 4 will give you here pi by 4. Pi by 2 minus pi by 4 will give you pi by 4 here. This is negative pi by 2. You know that cos negative pi by 2 or secant negative pi by 2 will give you the same thing. Cos pi by 2 and secant pi by 2. This is the property of cos. Sine minus x will always give you negative sine x. But if you have cos minus x, this will be finished. It will be cos of x. So this is written here. Tangent minus pi by 4. Minus will come outside. It will be minus tangent pi by 4. Now, secant pi by 4 is equals to under root 2 because you know that cos pi by 4 is equals to 1 over under root 2. So secant pi by 4 will be equals to under root 2. So this will be under root 2. Tangent pi by 4 is 1. Negative ln. Secant pi by 2 is again under root 2. And tangent pi by 4 is 1 here. You know that this is the property of ln. You can write these two functions with one ln. How? The positive thing will be written in the numerator and the negative thing will be written in the denominator. Now I am going to rationalize it. I am rationalizing it with this numerator like this. Multiply it and we divide it with this sign. Upper thing is same, so I can write it with whole square. The lower thing is a minus b into a plus b, that is equals to a square minus b square. So write it like this. In the denominator, I will get here 2 minus 1, that is equals to 1 here. And this is the property of ln, the power can be taken down. So it will be 1 over 2 under root 2 into 2 ln under root 2 plus 1. This 2 will be cancelled with this 2. So I will get here I is equals to 1 over under root 2 ln under root 2 plus 1 in my answer. So this question is proved. You need the same thing that we calculated here in this.